Hello everyone and welcome to the Royal Air Force Museum and the Centre for War and Diplomacy lectures. This is the first in a new series. I'm very excited that we're now collaborating with the University of Lancaster, and Marco Weiss, the director of the centre, is going to both introduce the Lancaster side of this and our speaker tonight, who is David Edgerton. It's a real joy for us all. But first, I'd like to thank all of you for joining us from around the world. We've got guests from Florence, San Francisco, and even Fleet. So truly a collective audience with us. And I'm going to pass over to Marco, and he can introduce both our speaker and himself.
Thank you very much, Harry, for the introduction and organizing most of this. I have the pleasure as director of the Centre for War and Diplomacy to say a few words about, in short, what is the CWD, and we're absolutely delighted to be running this lecture series in partnership with the Royal Air Force Museum, and particularly to have this very first talk co-organized with the Royal Air Force Museum, which will be given by David Edgerton. Now, the CWD provides the historical context and strategic analysis that will inform understanding of current global challenges, as well as those of the future. Embracing a global perspective, the CWD pursues research into the mutually informative fields of war and diplomatic relations between states in the longue durée, in order to combine cross-chronological insights. Based in the Department of History at the University of Lancaster, the CWD brings together colleagues from across Lancaster University's Faculty of Arts and Social Sciences, has a dynamic community of honorary researchers, and welcomes visiting fellows from across the world. The CWD also supports the MA in International and Military History at Lancaster, as well as a flourishing community of doctoral students who benefit from its program of conferences and seminars. So in my role as CWD director, it is now my pleasure to introduce Professor David Edgerton. David Edgerton is Hans Rousing Professor of the History of Science and Technology and Professor of Modern British History at King's College London. He taught at the University of Manchester before becoming the founding director of the Centre for the History of Science, Technology and Medicine at Imperial College London. He joined King's with this very centre on its transfer in August 2013. His first book, among many, was England and the Airplane, Warfare State Britons, another very famous book. And his most recent, The Rise and Fall of the British Nation, a 20th Century History, is now out in paperback. In today's virtual lecture, entitled No More Concordes, Aviation, Industrial Policy and the Future of the British Nation, 1945 to 1980, Professor Edgerton will survey British policy for British aviation after 1945, arguing that many really did believe that the UK's future lay in leadership in aeronautics. So thank you very much, Professor Edgerton, for giving this first lecture for the CWD RAF Museum lecture series. Please, Professor Edgerton, the floor, or should I rather say the screen, is yours.
Thank you very much, Marco, and thank you to the RAF Museum for jointly hosting this event with you. I'm very sorry that I can't be with you in Lancaster, where I've attended many enjoyable lectures, seminars, and conferences over the years. Now, the idea that Concorde was a folly, the last in a long line of prestige imperial follies, is a powerful one in the history of British industrial policy. And it's an old one. I'm of a generation that remembers the name Brian Trubshaw, and perhaps some of you watching do as well. Indeed, I'm also one of the generation to whom it's immediately obvious that Monty Python's Flying Sheep is a reference to Concorde, and that the Ministry of Silly Walks was the Ministry of Technology, which supported the Concorde. Remember the punchline of that famous sketch, the Anglo-French silly walk, La Marche Futile. Now, since the 1980s, there's been a very strong sense that the UK has really needed to get its act together in innovation, to make a serious national effort to innovate in the things that we know are going to be important for the future, or rather things we think we know are going to be important in the future. The story that came to be developed was that the UK had never had an active industrial or technology policy. The suggestion was that we had a policy of perhaps over-supporting academic scientists and indulging in, at best, mad prestige projects like the Concorde. Now, today, we have calls for an Advanced Research Projects Agency, ARPA, Dominic Cummings' baby. The idea is that the UK should finally get it right, should finally will the means to mobilize British genius to create the industries of the post-Brexit future. I want to take a different tack from these standard arguments. I want to suggest that we've been here before, but we've not learnt the lessons of that history. Indeed, we've forgotten that history. Concorde and its predecessors, I want to suggest, were not prestige or imperial hangover follies, but techno-nationalist ones. They were driven by a belief in a special British genius, which needed, desperately needed, to be exploited for the economic sake of the nation. I should add, still by way of introduction, that what I have to say differs from the standard narrative of post-war British aviation policy. I'm not going to talk about the Brabazon committee. Why? Because it misses out key airplanes, old and new, and crucially, the military context. Nor will I indulge in the "we was robbed" narratives, the stories of the cancellation of projects of world-beating genius. This swept-wing fighter, that jet airliner, meaning the V1000, and of course the TSR-2. Nor actually do I buy the great the great comet tragicomic stories either. In fact, I'm going to address the history of aviation in a slightly unorthodox way. I want to think about what airplanes were actually in use, as well as new ones being created. I want to rethink the nature of US dominance in aviation in the 1940s and 1950s. And I want to focus on an index measuring the nature of an airplane, which is surprisingly rarely talked about today, but a commonplace in the 1930s and 1940s, and that is the weight of an airplane. In this lecture, I'll be talking, when I talk about tonnages, I'm going to be referring to maximum takeoff weights. So what's my argument? It's straightforward. Successive British governments really, really believed that they knew what the technological future would be and invested heavily in it. They knew aviation was the key industry of the future, which it was vital to be strong in. From the Brabazon and the Princess, through the Britannia, the VC-10, to Concorde, there were serious attempts to build big, leapfrogging airplanes to take advantage of this special British genius, which was concentrated on the idea of the centrality of the jet engine. Now, there is no doubt, as Hermione Giffard has shown in great detail, that the UK was not just a pioneer of the jet engine, but was actually in the lead in jet engine development in 1945, ahead of Germany, that's to say. And it was most certainly ahead of the United States at that same time. Now, this was, in the view of the British government, not a lead to be squandered. Hence the extraordinary efforts that went into developing jet aircraft. So, the lesson is not that Britain failed to invest, failed to pursue its advantage in jets. The lesson is, I think, that there was insufficient analysis of the difficulty of challenging the great technological power that was the United States. And indeed, this is a standard problem in thinking about British industrial policy and innovation policy to this day. The forgetting that other countries are involved. There are other competitors. Now, back in the 40s and 50s, the only competition was the United States of America. Today, there is much more competition. But the arguments remain the same. It's as if the United Kingdom had no competitor at all, that the UK was in a position to shape the technological future, not just for itself, but for the world as a whole. I suggest this warning from the past. We've tried to shape the technological future of humanity, but succeeded only very, very partially. Now, from a British and indeed an innovation-centric perspective, the story of post-war US leadership in aviation is actually the story of a British failure. In this account, the UK had this priceless innovation, the jet engine, which it failed to capitalize on. It led the world in 1945. It got the US to license its jet engines. It was very successful in exporting jet fighters in the 1940s. But something went wrong. And what went wrong is the Comet airliner. The first jet airliner in the world. It flew high and fast and quietly, but not very far. It was in service in very small numbers, around 10 aircraft with BOAC. It was in service from 1952 until grounded in 1954 as a result of crashes resulting, as it became clear, from metal fatigue. The story then goes that the US was able to get the lead with the introduction in 1958 of the Boeing 707 and the Douglas DC-8. A redesigned Comet 4 also came into service in 1958, but it was too late and not strong enough to compete. Indeed, it only lasted for a few months on the transatlantic route. Of course, there is something to this story. It needs to be stressed, however, that the first Comet could not fly the Atlantic, unlike many similar sized and indeed larger piston engine types of the era. It was not the only aircraft which could fly above the weather. Most of the new US airliners could do that, though not as high as the Comet. The central point to make is that the Comet 1 had a maximum takeoff weight of 48 tons, which was small by the standard of airliners of the time. The Comet 4 was much larger. It came in at 71 tons. But the US competition in 58-59 was in rather a different league. The first Boeing 707s weighed, fully loaded, maximum takeoff weight of at least 110 tons. And the first DC-8 came in at over 120 tons. Now, putting weights and jets together and bringing in the military sector, again, gives us a different comparative story. The Boeing B-47 jet bomber came in at 100 tons, and it was in service with the United States Air Force before the Comet was in service with BOAC. Over 2,000 were built. Indeed, the B-47 was the first large jet bomber to operate from British airfields. It was not until 1955 that the smaller V-bombers came, the first of the V-bombers came into service, and all of them, at least in the 1950s, were smaller than the B-47 of 1951. In 1955, the US started using the B-52 of 220 tons and true intercontinental range. It was in fact called a global bomber. So the jet bomber comparison could be put something like this. In 1951, the US introduced the 100-ton 6-engined B-47, while the UK introduced the twin-engined 25-ton English electric Canberra. In 1955, the UK introduced the first V-bomber, the year the US introduced the B-52, 3 times larger at least. But there's more to say. The B-47 is rightly seen in the US as the aircraft which set the standard for subsequent large jets with its highly swept wings and podded engines. It leads directly not just to the B-52, but to the 707 and the DC-8. Now, what's the upshot of all this? It's essentially that if we widen the context for understanding the comet, it doesn't look quite as pioneering as is made out if one just looks at the issue of who had the first jet airliner. Many other factors were involved. By focusing on the comet, the British nation is rather flattered. We need to look actually not just at jets, but at US piston-engined aircraft. After all, they dominated in long-range civil aviation until really the early 1960s. It's only in 1959 that more large jet airliners were built than large piston airliners. In civil aviation, the large US aircraft dominated the skies, and they were powered actually by 3 engines. And I owe a lot of my thinking about the importance of engines to a PhD student of mine who just finished his PhD, actually jointly with the RAF Museum. It's Ted Young. The 3 engines were first the R3350, which powered the Lockheed Constellations, which weighed between 42 and over 60 tons. The R28 100, which powered the DC-6, which came in at 44 to 49 tons, both in service in 1946, both flying the Atlantic. Somewhat later, the R4360 powered the Boeing Stratocruiser, 67 tons, and we also had the DC-7 powered by the R3350, which came in at 65 tons. These are the aircraft that ensured US dominance of civil aviation. Long-range civil aviation essentially meant the Constellation, the DC-6, the DC-7, and to a lesser extent, the Stratocruiser. They all flew the Atlantic. They could all fly from, at least most of them could fly from one end of the United States to another. And they revolutionized aviation. It was thanks to them that in 1956, air travel across the Atlantic overtook travel by sea. In 1957, US domestic passenger miles by air overtook those undertaken by railroad, excluding commuter lines. In other words, it is these piston-engined aircraft that revolutionize travel. We don't have to wait for the jet age. Now, we can illustrate the extraordinary dominance of the US by looking at how long it took the UK to put into service a British aircraft of the size of some of these transports, and indeed of the 60-ton B-29 bomber, which was in service in 1944. In fact, it takes more than a decade for that to happen, with the introduction of the Vickers Valiant bomber in 1955 and of the Blackburn Beverley RAF transport in 1956. I'll return to that aeroplane in a minute. So this was the context in which the UK was forced to use large US aircraft. BOAC bought Constellations in 1946, 1948, and 1954-5 and used them into the late 1950s. BOAC also bought Boeing Stratocruisers from 1950 and a second batch in 1954, and they were in use through to 1959. And in 1956, it bought DC-7s, which it used to 1964. All, of course, piston-engined aircraft. These were the aircraft which could fly the Atlantic and were also used on many other routes. There's a similar story to be told about the RAF. It was forced to use B-29 bombers in the early 1950s, over 70 of them, in fact. They were called Washingtons. Furthermore, very large numbers of US B-29s, B-50s, and B-47s were stationed in the UK from 1948 onwards. Now, one only has to look at the engines and maximum takeoff weights of contemporary British aircraft to appreciate why this was. With one exception noted above, the Blackburn Beverley and one below, all British piston-engined aircraft, large 4-engined or more British aircraft using piston engines, used either the 12-cylinder Merlin or the 14-cylinder Hercules, actually with actually one exception, which is the short Sunderland and short Sandringham flying boats, which used a Pratt and Whitney engine, in fact. Indeed, every British aircraft of the late 1940s and indeed early 1950s, with a few exceptions, were derivatives of wartime airframes. The Avro Lancaster gave us the Avro Lincoln, the Avro York, the Avro Lancastrian, and the Avro Tudor, all Merlin powered. And the Hercules powered the Handley Page Halifax bomber, of course, the Handley Page Holton, which derived from it, and the Handley Page Hastings, and the Hermes post-war transports. In addition, the Hercules was used to power the short Solent flying boats. So that gives rise to a very particular question. Why didn't the UK use its larger engines and build larger aircraft? Because these are the American engines that I was referring to a minute ago were either 18 cylinders or 28 cylinders, a different scale of power of engine. Now, the UK did have some larger engines than the Merlin and Hercules at the end of the war: the Centaurus, the Sabre, and the Griffon. But all were made in small quantities. In terms of use in large aircraft, the Griffon was used only on the Avro Shackleton, which came into service in 1951. The Sabre wasn't used for any large aircraft. The most interesting case is the 18-cylinder Bristol Centaurus, because that was chosen for large, new British airplanes. It powered a prototype 45-ton prototype flying boat, the Short Shetland. It powered the Brabazon Mark I prototype and was meant to power the first version of what became the Bristol Britannia, which was to have weighed only 47 tons. But the only large aircraft that came into service using the Bristol Centaurus was the already mentioned Blackburn Beverley, which came into service in 1956. There's an intriguing suggestion made in 1946 that the Centaurus should be used to power British-operated Lockheed Constellations. But this was turned down on the grounds that it would damage the prestige of the British aircraft industry. Now, why wasn't the Centaurus, which had proved itself to be an effective and an efficient engine, for example, in the twin-engined airspeed Ambassador, used to power large aircraft? I think the answer is the British obsession with the jet. And the obsession with the jet was not just a matter of the Comet. The jet was central to all the large projects. The first Brabazon was indeed powered by the Centaurus, but the subsequent ones were to be powered by jet engines, the Bristol Proteus turboprop. The Bristol Britannia would also be developed with that same engine. And the power plant for the prototype Saunders Roe Princess flying boat, which flew in 1942, was this very same engine. Harry, can I ask you to put up the first slide? This is from Look and Learn for children, and we have next to each other, as they should be, a picture of the Saunders Roe Princess and the Bristol Brabazon. For some reason I don't understand, the Princess is referred to quite rarely, certainly by comparison with the Brabazon. Now, those are two massive ones and one big one. The UK also developed a small jet engine aircraft, the Viscount, which in its first version weighed only 17 tons. The larger version came into service in 1953 at 20 to 30 ton range. So we have effectively two leapfrogging strategies. Going for huge size and going for jet engines. The aim in the Brabazon project was to build the largest civil airliner in the world, bigger than anything the US was planning. It really was on a different scale from other airplanes, including US airliners at the time. It was to weigh 130 tons. It was called a future Queen of the Skies. The Saunders Roe Princess was even larger at 150 tons. The Brabazon had 8 Centaurus engines. The Saunders Roe Princess had 10 Proteus engines. Now, the outcome of this double leapfrog to jets and to very large jets was dismal. The Brabazon was cancelled in 1952 with only the Centaurus powered version ever built. The Saunders Roe Princess likewise cancelled. The Comet 1 was, as we know, only in service in very small numbers, very briefly. But of course, the Vickers Viscount was a very significant success indeed, but of course a small aeroplane. The problem was that in all aspects, really, the UK was in fact behind the US, as well as being behind in jets by the early 1950s. The US was also ahead in large airplanes, both land planes and flying boats. The US built larger and earlier using piston engines rather than jets, in particular using the R4360, this massive 28-cylinder Pratt & Whitney engine. This engine powered the B-36, larger than the Brabazon and in service before the Brabazon even flew for the first time. Indeed, there's a British newsreel of 1951 which notes with some reluctance, this is in the B-36 on a visit to the United Kingdom was in fact larger than the Brabazon. The famous Spruce Goose flying boat, which flew in 1947, was larger than the Princess and was again powered by the 4360 Wasp Major engine, 8 of them in fact. So jet-powered piston engine powered American aircraft of huge size beat the British giants into the air, and indeed one of them goes into service. And of course, the US also continued to win the race for size with jets. The 220-ton B-52, and I've already noted that the Boeing 707, when it came into service, was nearly as large as the Brabazon and would become bigger in time. And the Comet 4 and the later Britannias came in at around half the size of the Brabazon. So the dominance of the US in large aircraft remained total. It proved impossible to leapfrog ahead of that great aeronautical power. Indeed, it's worth noting that not only did the UK buy some of the very big American airliners, but it also bought slightly smaller DC-4s manufactured in Canada and using British Merlin engines, and that was in the 1950s. So one really has to ask the question, why is it that the UK seemed not able to develop a DC-4 equivalent in the late 40s, let alone an equivalent to the Constellation or the DC-6 or the DC-7? So there's a problem with engines and also a problem with airframes as well. A double question. So what happens next? Well, the Britannia and Comet come into very limited service in 57 and 58, at the same time as the V bombers, but all smaller than US types of that era. In the late 50s, we have two big projects starting out anyway, the VC-10 and the Concorde. Now, this isn't much noticed because we don't pay enough attention to weights, but the VC-10 was as heavy as the Princess, 150 tons. And the Concorde was even larger, 180 tons. It doesn't look it, but the Concorde was the largest British aircraft ever built. Perhaps at this point, Harry, we can just just to show that size is not obvious from images. We'll go through some images. This is I think a rather beautiful photograph of the Brabazon in front of the Brabazon hangars at Filton, built for the Brabazon. Those hangars are still there. They were at the time, I think, the largest span of any building in Europe. British modernism very clearly on display here. Should we move to the next one? A colour photograph of the Saunders Row Princess. These aren't very common, but I think the colour adds to the sense of this being an airplane of the recent past rather than the distant past. You can just about see the 10 engines. The outer engines have one propeller. The inner pairs have two propellers each. Let's go to the next one. The Bristol Britannia, also using the Bristol Proteus engines. Smaller than its Bristol predecessor and its Saunders Row predecessor as well. Let's go forward to the next one, the VC-10. As I say, larger than, or I should say, the same size as the Princess. And finally, we have a picture of the Concorde, rather unusual picture of the Concorde as it's being built. As I say, the largest British aircraft ever built, though but that's by weight and not volume. In fact, it is in many ways a flying fuel tank, and that was indeed the problem. Now, the VC-10 represents, I think, a very important catching up with the US. It is an aircraft which is close to the 707 and DC-8 in performance, but perhaps not close enough. But I think it's the first time you get a matching of the aircraft of these two nations. The Concorde is another matter. This was another leapfrog, a leapfrog into, of course, supersonic speeds. And a leapfrog this time actually with the French, but against two competitors, the US and the USSR. It was not at first alone. I think it's important to remember that. It was a gamble on the future, and it was a gamble that failed. It continued to be developed long after it was known to be a certain commercial failure. And as my student Tom Kelsey, who's just finished his PhD, shows very, very clearly and importantly, the Concorde was effectively cancelled in 1974 when the decision was taken to build only 14 production Concordes. The previous plans had involved many, many more machines. In fact, many, many more would have been required to make Concorde a profitable aeroplane. Now, the Concordes, of course, found their own niche, but they certainly weren't the history, or they certainly didn't become the future of aviation. My point here is that Concorde was not a one-off. It was the last in a line of attempts to leapfrog with jet engines and large size, and in this case, speed as well. Leapfrogs into the future which all failed. They were partly leapfrogs into the future because that future had already happened. The Americans had got there first. Not in every case, of course, but in the case of Concorde, because they cancelled, and they got there first by cancelling first rather than flying the aircraft first. So what's the point here? It's also that the Comet was not the only leapfrog. The Comet and the Concorde weren't the only leapfrog. And indeed, the Comet wasn't a particularly impressive attempt at a leapfrog in terms of expenditure or in terms of size. Now, how was this experience reflected on? It was a story which was known to people interested in British industry. It was a story which was pretty universally regarded as a story of failure. And indeed, in the early 1960s, this understanding led to a fundamental reappraisal of British innovation policy. The idea developed that the UK couldn't afford to have any more Concordes. There was, in fact, a general disillusion with innovation, with R&D as a route to British, to a glorious British future. Curiously enough, Harold Wilson's white heat policy, which is often seen as the one moment in peacetime when innovation and industrial policy combined and turbocharged, were put into the center of British policy, in fact, represents this moment of disillusion and change. The basic idea behind the white heat policy, and indeed the white heat speech, was that previous conservative governments had invested in what were then called prestige projects, which went nowhere commercially. In the future, the United Kingdom, it was argued, should spend less on high-tech defense projects, less on prestige projects like the Concorde, and spend more on bread and butter R&D, bread and butter industries. Indeed, from 1964 onwards, the British R&D GDP ratio falls. British R&D GDP peaked in the early 1960s. It's still quite a way below the record levels of 1962-63. There was a move to European collaboration, not least in aircraft, a move to buy US aircraft more systematically, indeed in some cases to put British engines into US airframes. The 1970s see essentially an acceleration in this disillusion with British high-tech. Concorde had survived just, but to be cancelled in this rather special way of just being produced in very, very small numbers. But one big national project after another comes to be regarded as economically misconceived and is cancelled or otherwise stopped. How does this play out in analyses of industrial policy? Well, the fundamental idea developed in the 1960s and strengthened through the 70s and 80s was that the UK had overinvested in defence and prestige projects, and this had crowded out good, solid, honest, commercially viable R&D programs. That became the standard argument in the science policy literature when it considered the broader question of British economic performance. It was a kind of misallocation model, and it compared the UK with Germany and Japan, who it was suggested were not so foolish as to invest in these two areas, and therefore succeeded in their modernization. In this model then, Concorde was one of the things to blame for poor British economic performance. I think this argument is wrong for two reasons. First of all, British bread and butter R&D was higher than that of Germany and Japan into the 1960s. And secondly, spending more on R&D was even the right sort of R&D was no guarantee of faster economic growth. So the whole focus on R&D is somewhat misleading. Let me bring this to a close by asking, what's the point of this story in relation to contemporary policy? Well, if the UK had been the only country in the world making large jet airplanes, or the most successful in the 1940s or 1950s, the story would have been different. The UK would have been in the position of shaping the future of aviation through the choices that it made. Its aeroplanes could then have been arranged in a chart outlining the progress of all global aviation. Jet Brabazons and Princesses and Comets would have been flying around the world through to the 1960s to be replaced by large numbers of VC-10s and then Concordes. They would all have been hailed as great successes of industrial and innovation policy. But the reality was otherwise. It was not the UK that was in that defining role, but the US. And it defined long-distance large aircraft in the 1940s and 1950s as large piston engine machines, which British jets of that era could not match. And indeed, it's continued to define aviation to this day. But it's met its match, it's civil aviation at least, in Airbus. And that, it could be argued, was not so much the product of leapfrogs as of steady advances. Think, for example, of the Caravelle, a French aircraft, but with British engines, and indeed a British nose as well. Now, these arguments discomfort the science policy experts, the arguments that I've been making, and for good reason. For what I've been saying is that British engineers, politicians, civil servants had the future in their bones. They believed, and with good reason, that aviation would be a very important technology of the future. They weren't wrong about that. Nor indeed were they wrong about the British lead in jets in 1945. Why does this discomfort policy experts? Well, because their argument has to be that these British experts of the past, these politicians, civil servants, got it wrong in choosing the technologies that they did. Today, the claim is the UK is in a position of choosing properly in a way that the experts of the past seemingly were not. But who's to say, actually, that the experts of the past were better at predicting the future, or worse at predicting the future, than the experts of the present? But that's not really the point. The essential point I want to bring home is that in thinking about innovation policy and industrial policy, you've got to think about the competition. And the lesson to be drawn is surely that the competition the United Kingdom faces today is much greater than the competition it faced in the 1940s and 50s. That even then, it wasn't capable of winning against a seriously superior power. On that depressing note, I will end and invite you to throw your comments at me. Thank you very much.
Okay, thank you very much, David. I'm going to pass over to Marco in a second, who's going to chair the Q&A session. Whilst we let you catch your breath, however, I think it's a good opportunity both to thank you for a really fascinating talk. It's very rare that I listen in the middle of a lecture and think I'm definitely going to have to listen to this again. Fortunately, I can with this format because it really was in depth and I enjoyed it greatly. I should say to our audience, if you have a question, I know some of you I can see have already posted them. You can do so in the Ask a Question function. Marco will be hopefully able to find them and put them to David. But I should also say that we have 2 more lectures in 2021 at the RAF Museum. The first is on the early V-Force with Alan Jackson, who is a PhD student at King's College London. And the second is on Forging the Future, the advent of all-metal aircraft with Dr. Matthew Powell. I'm really jealous that Matthew's got such a good title there. So those are on the 13th of November, a Friday, unlucky for some, and on Thursday, the 19th of November. And you can find them both through the Royal Air Force Museum's Crowdcast channel. It's also a good opportunity for anyone who's watching and thinking they might like to give a paper with the Royal Air Force Museum to say, our call for papers will go out at the end of this year. You're more than welcome to get in touch informally and discuss them. But without any further ado, I'm going to hand over to Marco to chair this session.
Handing over, and of course, thank you very much, David, for this fascinating talk. I myself did quite a bit of research on jet exports, mainly, and so of course I'm familiar with quite a bit, but not necessarily with this argument, which I really thought was absolutely thought-provoking. So I want to monopolize the floor here because there are plenty of questions coming in. We already have 14, 13, 15, etc. I'm gonna put the first one I saw at the very beginning to you, which is from David Dawson, and he's asking, so 50 plus years ago, I lived within 2 miles of Woodford, Cheshire, where the Avro Vulcan was built. So much British aeronautical innovation in the 1950s. But what about now? So that's a question perhaps you'd like to answer. What about innovation now?
Yes. Yes, well, I mean, back then there was indeed an extraordinary amount of innovation, and that maybe gives me a chance to actually plug RAF Museum Hendon and Cosford, which are both open and wonderful places to get a sense of this extraordinary burst of innovation in the 1940s and 1950s. Where are we now? Well, essentially we have a European aircraft industry, and some bits are very successful. For example, the making of the wings for Airbus in the UK. The difficulty is that Brexit is threatening that aeronautical industry very gravely indeed. But
Thank you very much.
I think that's the first thing to say, is that although we tend to think of jet aircraft today as British, and they're sold as British exports, in fact they are European machines, not exclusively British.
Thank you very much, David, and thank you for the question to the other David Dawson. So the questions are not necessarily in chronological order, but I will go for the one with the most votes. And Nexus 41 asks, what role did the 1970s oil crisis play in the decline of UK commercial plane manufacturers? Did they react fast enough and produce more economic designs? I've read that the VC-10 fell victim to the increased fuel costs.
Yes, I mean, of course, the VC-10 and the Concorde are the last large British aircraft to be designed, and that work is done by the time of the first oil crisis. So I don't think there's an answer to the question. In fact. Thank you.
Now, a question from Tim, I don't know, I think it's Tim probably. He's asking you, given your comments on industrial strategy in the past, what do you think about the idea of a UK DARPA?
Yes, what I think of it, I suppose the answer was implicit in my comments. I think it's an absolute nonsense. We have to remember that that DARPA in the 1950s and 60s was a tiny part of the R&D effort of the Department of Defense in the United States, which had by far the largest R&D budget of any organization in the entire world, in a country which produced something like half the industrial output of the world, and was clearly way ahead of any other country in technical innovation. Yeah. In that context, it makes perfect sense to have a DARPA, to think up kind of really wacky ideas that other people aren't thinking up. If you have 2% of global R&D taking place in your country, not actually necessarily under your own control, if you are the 6th economy in size in the world, and there isn't much difference between the 5th, 6th, 7th, 8th, 9th, and 10th, you're in a very different position. The reality, well, and on top of that, you have levels of industrial productivity that are 20–30% lower than, say, Germany or France. You are in a completely different position from the United States in the 1950s and 1960s. And I would suggest that DARPA is the last thing you need in order to make your economy more successful. And we need, frankly, a policy of imitation, not a policy of radical innovation. And the UK is an innovation taker. It has to be an innovation taker, just as it has to be a rule taker in world markets.
Thank you. Then the next question from Ian McFadden. What do you see as the key balance between R&D investment and understanding the market fit?
Well, exactly. Is there a general rule? Perhaps not, but there's certainly a very strong view around British aviation that there was not enough emphasis on market fit and too much emphasis on innovation. On the other hand, the argument is also made that in some cases there was too much emphasis on a particular market fit and not enough on innovation. And a classic example of that would be the VC-10. The argument there is it was designed for the particular requirements of BOAC for a shortish takeoff and landing from hot and high airfields, which disadvantaged it in routes such as the transatlantic route. So it's very difficult, I think, to give a general answer to a question like that.
Thank you. The next question is a brief one. Where did the TSR2 fit into this, by Robert Lowe?
Yes, well, the TSR2 is one of these cases where people argue that if it had been continued with, it would have been a great success. I'm not competent to decide whether that's right or wrong. In fact, it's very difficult to make those kinds of arguments because so many different factors are involved. But I suppose the thing to say about the TSR2, it does involve a recognition that the UK wasn't in a position to carry on developing many different aircraft simultaneously. So the idea behind it is that it's essentially to create a multi-role aircraft into which one can concentrate a lot of innovative effort.
Thank you. The next question is from Nexus 41. In view of COVID and Brexit, how do you see the future of the UK aerospace industry? Should we be worried? And what role should UK industrial policy play? I think these are three questions in one, pretty much. Yeah.
I think we should listen to what the people in the industry say, and they're clearly worried about both, because of the interconnection of the manufacturing industry and of course the massive effect of COVID on airlines. So yes, there is good reason to be worried.
Thank you. The next one is also quite topical, by Mark Russell. Could Britain ever develop world-beating companies given its size versus the US and China, because their domestic markets are so much bigger? And in the case of China, you'd have to be incredibly better than the local product to make big inroads there. So is Britain always doomed to come second because of the size of its domestic market?
No, no, it's not, because it could happen that the UK does produce a company that does, for whatever reason, succeed in those markets. But the thrust of the question is absolutely correct. That if we're thinking about kind of competition between kind of national formations, the chances are that the UK is going to lose. Now, if we don't think it so much in terms of national formations, but a global market, then it's very easy to see the possibility, at least, of British firms succeeding all over the world. But for British firms to succeed all over the world, and actually British government-sponsored projects to succeed, we need to recognise the existence of the United States and of China, and indeed of Germany and Japan and so on. Far too many discussions of what we should do just assume that the United Kingdom is the whole world, and that we don't have to be concerned about what other countries are doing and their relative strengths in innovation and in industrial production. So that's my central point. You've got to take account of the rest of the world. And so often we don't do that.
Thank you. And that's another one perhaps which connects well to the previous one by Ingeniogi, who's asking, so how do we explain German industrial progress in this period? Yes,
and it's important to stress just how successful Germany is. Germany exports much more than the United Kingdom. It exports much more than the United Kingdom outside the European Union. In fact, it exports twice as much as the UK does to Australia, to New Zealand, and to Canada. And that's something that the advocates of a Kanzuk might bear in mind. Why is Germany successful? Well, the standard answer is that it's very good at what's called medium tech, and it's not obviously the most successful nation in terms of the things that we call high tech. It's good at cars, it's good at machine tools, it's good at capital equipment. The Chinese buy enormous quantities of German capital equipment, indeed. So I think the short answer is German success is not to be put down to an obsession with the highest tech.
Kind of pragmatism. So the next question is from Louis Smith. Fantastic talk. It seems that BOAC were the face of these prestige projects. Oh, hang on, the question's just been pushed down while I was reading it. I'm going to try to, oh yeah, there it is. With the face of these prestige projects, where does the nationalized BOAC stand in all of this?
Yes, BOAC was effectively charged with supporting British industry with buying British. but for most of its history, it didn't want to do that. And indeed, aircraft industry suspected that it was out to undermine the British aircraft industry. So it both supported the industry by buying British, often where no one else would. At the same time, it bought overseas, sending, of course, a very negative signal about British airplanes. And it's important to remember generally, actually, that all the nationalised industries were enjoined to buy British, and that they generally, more than the case of aviation, did buy British. So the electricity generating authorities bought British nuclear reactors, British designed, British built nuclear reactors. The post office bought British designed and built equipment. The railways bought British railways. With privatization, things have changed radically. So most of the equipment that goes into infrastructure now comes from around the world, not from the UK. Some, of course, does, but certainly not nearly all of it, as was the case outside aviation. So we live in a radically changed economic context. Into the 1970s, most of the manufacturers around us, and those of you who are kind of my age or above will remember this very well, were British made. The majority of cars were British, trains were British, ships were British, pots and pans were British, knives and forks were British, tables, chairs, everything was basically British. It was a very, very different world.
Next question from Addy Osborne. Very much liked your talk. His question is, do you think that the success of the US over UK development was partly a cultural issue? The American yes we can attitude over a rather ponderous British approach?
I don't agree with that, actually, because I don't think the British were ponderous. I think going for a Comet and going for a Brabazon and going for a Princess and then a Concorde isn't a sign of ponderosity, if that's the right word. I think the fundamental difference is actually not just scale, but the wealth of the United States. Per capita income in the United States was double that of the UK in the 1940s and 1950s. If you take the index of car ownership, in the UK, you get levels of car ownership in the late 50s, early 60s that the United States had in the late 1920s. It's a very, very big difference. The Americans could just throw resources at technical development, and that wasn't. I mean, there was a kind of British idea that it was British brains versus American brawn when it came to innovation, and there's, I guess, something in that. But we shouldn't underestimate the extent to which the US, with its own technical resources, was able to pull ahead of the UK. And these great piston engines of the Second World War and the immediate post-war years are a very nice example of that. Thank you.
Mark Parry would like you to expand on the British nose of the Caravelle.
My understanding is that it was licensed from de Havilland. It's very similar to the nose of indeed the cockpit of the Comet. I stand to be corrected by somebody more expert than me in this matter. Certainly looks similar. I did check that.
Thank you. The next question is from Alex, and he's asking, you're trying to avoid the Brabazon committee, but the focus on size seems to beg the question, didn't the decisions to pursue specific weight classes flow from it?
I'm not sure I understood the question. Weight followed from?
So didn't the decisions to pursue specific weight classes flow from it, but focus on size. I think he's focusing on the issue of size. That's the question.
So why did the UK go for size?
Yeah,
for extreme size in this particular case. Yeah, I don't know the answer to that. It's an interesting question. I mean, the suggestion is made that this was simply a delusion. Yeah, to go for that sort of size. I think that's wrong, because the UK wasn't the only country going for aircraft of that size. I think what's particularly striking about the British case is they go from being able to build 30-ton airplanes to 130 tons, whereas the US had plenty of 60-ton airplanes. So it's the jump, as it were, rather than the size that's the issue. And the other point that's often made about the Brabazon is that it harked back to a pre-war era of luxury travel, and this is why it was only going to carry a small number of passengers in great luxury. I think that's wrong for two reasons. The first is that actually the Boeing Stratocruiser carried people in some luxury in the 1950s, and secondly, the idea to just carry 100 people was a plan. They could have changed the layout and carried many more. I don't think it had any particular effect on the structure of the airplane itself.
Thank you. Next question is from Lewis Edwards, and asking, while not relevant to the time period discussed, but relating to your emphasis on innovation, do you have any thoughts on the new Tempest jet fighter project?
No, I think, but in that I don't know the details of that fighter, but it is very striking that the suggestion is being made that the UK should once again be developing and building its own jet fighter without collaborating in Europe. In other words, we're going back to the late 50s, early 60s. That would be a dramatic change, and indeed a dramatic change of direction from what the policy recently followed of buying F-35s, which the level of British content is relatively low. I mean, my guess is that the government will not go with the Tempest. Now you might say that we have a very nationalist, levelling up Brexiter government. My response to that is that we don't really. We actually have a free trading government that isn't interested in the development of British industries, and perhaps especially not British industries that already exist. If they're interested in British industries, it's the ones of the future that are going to be developed through DARPA. I mean, hence the willingness to throw the existing aircraft industry, car industry, some extent pharma industry, to one side in the Brexit negotiations.
Thank you. Then from Paul Nuttall, is a turbojet powered Brabazon or Princess possible at this time?
I mean, to do it again.
Well, I think that's the question. I'm not sure.
Yes. Well, I think the answer is that we're way past them in terms of size. I mean, the airplanes that we routinely travel in today are very much larger than either. Again, the way we see airplanes doesn't make that very obvious.
Thank you. Then we have a question from Richard. He's asking, did the narrow specs for BA and BOAC, which could be changed for short-term needs, for instance, Trident made too small at the start, and so always catching up with the Boeing 727 to get bigger and more efficient?
Yes, I mean, that is an argument that's made that these the very particular requirements of British airlines translated into airplanes that other airlines around the world didn't want. And it's an argument indeed applied to the Trident and to the VC-10.
Marco, I think we've got time for one more question.
Yeah, one more question, and I think yes, they had their questions pretty much. So, question from Bruno. What do you see as the next breakthrough in aviation of the future, such as the Concorde and SST was 50 years ago? Out of the future is the last question.
I have no idea. I have absolutely no idea. And if I did have any inkling, I certainly wouldn't broadcast it to the huge numbers of people that I see are listening in. I would talk to my stockbroker first. But it's interesting to listen to Boris Johnson talking about zero carbon British airplanes of the future. So we have some very kind of retro dreams of technological superiority informing current policy. And indeed, it's fascinating to see just how retro so many of the digital gurus of our time are. They're into space rockets and things of things of that sort. My guess is that the future will be somewhere else, and certainly not in what Dominic Cummings calls moonshots.
Thank you very much for taking all these questions. Of course, sorry for some questions that haven't been answered. One was not really a question, was more of a comment, and others were questions actually by some who had already a question answered. So thank you very much for so patiently and extensively answering all these questions, David, and for an absolutely fascinating talk. And alas, we can't give a round of applause, but of course, please express your appreciation for David and his talk in the chat function if you'd like. And perhaps in this case, they're going to hand over back to Harry.
Thank you very much, Marco. My pleasure.
Yes, well, I'd just like to echo Marco's comments, David. Massive thanks for taking part, but also to thank all of our audience for tuning in. And as I say, if they'd like to follow any of our other lectures, do so by following our Crowdcast channel. So our media manager will be very pleased for what I've mentioned. And thank you also for the plug. People should indeed come along to the museum in Hendon and Cosford. But all that's left, I think, before we end is to say thank you one more time. So thank you very much.
Thank you.
Thank you.